Hey, welcome back to the channel. Good to see you all again. Hope you're all well. Today on the bench I have a JVC quartz locked QL F4. This cover doesn't belong with it. It was just brought as protection. This is a fully automatic direct drive turntable, and it was my regular client brought me this. He says, could you please look into the speed regulation on this, because he would be listening to it and then it would be going whoop, it would speed up, and he would fiddle with the speed switch and it would return back to normal. I think the switch is just dirty, it needs a clean, and he just wanted to check it over, make sure everything's good. He says the tone arm he set up himself, everything's 100% with that, so I don't have to bother with anything there. But he does want the power supply, motor, servo checked out, and the speed switch dealt with. And also he has another annoyance. It was the where is it now? Back here. The ground lead for the turntable is been cut short, and he wants me to extend it and put a spade lug on it, so I can do that as well. So let's have a look at this. Let's plug it in and try it out. Okay, so I'm just going to go through and check the functions. I'm not going to play the album. I'm going to leave the guard on the Stylus down. So I'm just going to hit start. We'll see how it performs. Okay, so that's fine. It's got a repeat function. I'm not going to test that right now. I'm just going to move this over to the lead out. So everything appears normal. Alright, and the speed regulation, I just want to check it here. There is a strobe light here right at the beginning, at the front, and I can see, if I turn the lights off, it's a lot easier to see. I don't know if you can see that, but it is locked in. Switch it to 45, it locks in. 33, it locks in. So it's all functioning normally. Let's remove the platter and we'll have a look at the motor. Alright, so I removed the cartridge just so it doesn't get damaged. We don't need that in place right now for what we're doing. Rubber mat. Looks pretty good condition. Platter's got some good weight to it. Here's the mechanism for the automatic business. Okay, that's working. It's not running at speed right now because I have the platter removed, so it's going actually slower than what it should be. So everything looks good up here. There's really not any lubrication you can use. You can lubricate these big gears. I can pull one of those off and they can lubricate. It's not going to help much. It's actually fine the way it is. There's nothing really to do here. So let's lock this down and we'll flip it over and we'll have a look at the electronics of this thing. Okay, screws are out. There's actually a couple missing. We'll have to replace those when we put it back together. Not too bad. What do we got going here? Interesting. It's got a lot of wax on the electronics board. Okay, we can deal with this. So we can take the motor out and lubricate that. It probably doesn't need it, but I'll take it apart and clean it and redo it anyway. A lot of this stuff here, we can lubricate some of this, but generally it's pretty much trouble-free. Looks like there's a voltage regulator here, stuck on a little piece of aluminum for heat sinking. Electronics board, power supply. We have 2 fuses actually. I got it unplugged. Here's our speed switch. I'll have to remove this and clean that switch. Little power supply and servo board just to run the motor itself. Everything looks pretty good. Okay, where to start? Let's take out the motor. Start with that. A little bit of friction there. We can relube this. Looks like the magnet might be rubbing here. I'll check that. If that's the same, I'll check the distance from the shaft. If that's the same, then that's a rub from the magnet. We might have to shim this a little bit. It shouldn't be rubbing like that. Everything else looks good. Okay. Here's a quick look at the mechanism inside. We've got the mechanicals on this side. This is the automatic. There's a repeat button here. It sets it up to repeat mode, and then it counts down and ratchets down. This is the automatic and queuing. Queuing's up here, I think. This is the phono wires. They're shielded. I don't see anything going on here. Looks pretty good. support for the motor, power transformer. It's isolated on the rubber mounts here. It just hangs upside down on this rubber, so it's not going to provide any mechanical hum pickup onto the turntable. It's pretty good feature. There's our fuses. 1/2 amp. I don't know what it is. I should check it. And what does it say? 125 volts, 500 milliamps. Somebody put some tape on this shroud. Why would they tape it up? It should be 125 volts, 500 milliamps. And what is this? This is, this is 600 milliamps. Okay, well we can change that. Somebody put a little note for the future tech. That's for me, I guess. So we'll get the right size fuse in there. Yeah, this is 600 milliamps, 250 volts. Okay, we'll fix that. Let's check the other one here. This one here is 500 milliamps, 125 volts. If you can't see that, can you? Let me crank this up. So this is a 500 milliamp fuse too, and this is correct. So we'll leave this one in place. I wonder why they got two fuses. One's for... It's wired in the primary or secondary. This one's wired in the secondary. This one's wired in the primary. Let's see if we got a fuse. Milliamps. There's 500 milliamp right there. Okay. All right. Actually, what I'm going to do is I'm going to turn this around so I got access to the electronics board. But first I want to lubricate the motor. So let's do this. This magnet here, you just don't want to let it down anywhere because it'll pick up all kinds of junk. So just leave that. Let's wipe off the old grease, the old oil. Okay. All right. Yeah, it's pretty dry. I think this would benefit from a relubrication because it looked like it was pretty dry. Okay, let's see here. Just going to give it a clean with some contact cleaner and clean all the residue out. Not much in there. Coming back fairly clean. So I think we got it. Looks pretty clean in there. Okay, so let's re-lubricate this. I'll use my synthetic grease again, if I can find it. So what we need is we need a little bit on the tip, because that's a friction bearing right here on the tip. And then we'll give it a liberal coat on this shaft. Won't take much, it's just a little bit. Okay, I think that's going to be good. Once I put it together and start rotating it, it's going to spread around. It felt like it was dragging. It is catching on something. I can feel it. You got a piece of grit or something. There is some small amount of grit. No, there's something wrong here. Maybe that isn't from the magnet. It looked like it was close to the magnet. I guess it wasn't. Okay, so I'm going to figure out why this thing is not playing nice. Let me give this a good clean. Okay, I think I got it that time. I had to take a cloth and wipe off the magnet. I think there's some dust on there. Let's give it a little bit more lube. Just a touch more on the shaft because I think it would benefit from some extra. And now that I think about it, I wouldn't be able to shim this on here because the bearing is on the end. That's where the friction is, and that's where the height comes from. So if I wanted to shim it, I would have to pull out that nylon disc or whatever's in there and add some height to it. So there we go. Okay, put this back together. Alright, so I was looking over this board and I did some ESR tests on all these electrolytics. They all tested fine, except these two. These are 47 microfarad at 50 volts. And they have an ESR probably double of what they should be. So I'm just going to pull them out and test them out of circuit. And pop a new one in if we need it. We got them here. No sign of leaking, which is good. So let's try this out. And what do we get? 41 microfarad, or 42 actually, and a 1.5 ohm ESR. That's no good. Let's try the other one. I don't expect there to be any cooked capacitors because this circuit, this one looks like, no, I don't think it was leaking. Right. Let's see this one. This one's a little better. 43 microfarads, 1 ohm ESR. Should be around half an ohm ESR. So I'm going to replace those two. Something else I want to do is I'm going to remove these two capacitors. These are the main filters. They're 220s at 50 volt. And I want to clean all this spooge out from around it because it's just going to cause problems in the future. Surprised it hasn't caused problems already. All these components are just drenched in it. So I'm going to remove those as well and clean this up. They clean up this board. We don't need to dump crap all over the board to anchor caps down. We can do other things too. We can use silicone. It doesn't make a mess and it doesn't short parts out. Okay. These are not leaking either. These are. Let's test this one while we have it out. Maybe we can replace these as well. So it measures 204 microfarads, 109 milliohms. I think that's well within spec. So I'll just leave those in. I'm just going to clean this board up. Let's try this one. This one's the same thing, 201 microfarad, 111 milliohms. Okay, so I'm just going to clean this board up. Nasty stuff. Okay, got the electronics board back in place. Got two new capacitors in here. Replaced the originals back here. Cleaned out all this mung. Like, look at how it stains the board. This stuff is terrible. It soaks right into the printed circuit board and stains it. And causes all kinds of problems. There's a transistor here. And there's diodes here. And there's things that are getting shorted out. So that's all cleaned up now. Two new caps. And what else did I do to this? That's about it, I believe. I checked all the solders for cracks and I didn't find any. So this is ready to go back together. Now the last thing to do is clean this switch. It's kind of a unique mechanism here. I think they could have made it a little more complicated. But here it is. So cleaning the switch, best thing for this right now is the D5 spray, and I'm going to give this a shot. And actually got to go like this. I'm going to get told I'm using too much, and just work it in. If we had to, we could check the contact resistance. That's probably what I should have done. I should have checked the contact resistance before I started. But okay, well, let's try this. This won't be very good at checking contact resistance. I'll let you know that right now. Zero. Zero. Okay, that's all I can do for it at this time. I'll put it back together. Put it back together, all done under here. I had a good look at the rest of this mechanism, and I don't think it needs lubrication. It's all working great, just perfect. There's nothing here that's really dried up or not working. I could check this switch too. Try that right now. It doesn't want to reach. So yeah, we're floating around 1 ohm, 1.1 ohms. Let's see here. Okay, now it's closed. And we got about 10 milliohms. So that switch is okay. 10 milliohms, nothing to complain about. Why do we have 1 ohm when it's open? I don't know what that switch does. It's the main power switch, I think. Okay, we'll put this back together and then we'll flip it over and give it a test. Okay, we're all back together now. Just wanted to test out a few things. Strobe speed. I don't know if you can see this on the camera. I'm going to try this. Try zooming in on it. See if this works. It's locked in at 33 1/3. I'm going to kick it up to 45. And it locks in quickly. Turn it back to 33. And it has to slow down. Seems like it's working pretty good. It's not drifting. It's not wobbling. Down to 33 again. Seems like it's functioning okay. Alright, so another thing I did is I added a spade. Well, here I'll show you. On the ground, I extended the ground wire for the amplifier, and I added a spade on the end. And this is silicone wire. It's test lead wire actually. It's really fine strand. You could flex this all day long, and the strands won't break because they're so fine inside. So this is probably an ideal wire for this. So that's good. That's all done. Next thing I want to do is I want to check. He said he set up the tone arm. I just want to check the weight of the stylus. Okay, I think I'm going to need to unplug the turntable, because we don't want it spinning on us. Let's put this here. Okay, 2.78 grams. Now I don't know if when I was doing some cleaning maybe I bumped the counterweight, but let's see here. I think he said he had it set up for 2 grams, so we can just do this right now. Here, let's put this 233. Okay, now I'll just turn the scale to show 2, and we should be there. 193. Two right there. Okay. So I think we're at 2 grams. Okay. I'll leave it at that. And if he wants to adjust that himself, he can do that. Just that he mentioned that he didn't have a scale, so it is set for 2 grams now. Let's hope it makes it home before it gets knocked out of alignment or adjustment. So that's pretty much it for this. I don't have anything else to do for it. We changed 2 caps in the power supply, changed fuse to the correct current, relubricated the motor, and did a little bit of cleaning, and it's ready to go back. All right. Thanks for watching. I know it was a short one, but what can you do when there's not much to do? All right. Thanks for watching. See you on the next one. Take care.